This is Michael Elms. In this video, I'll be covering problems that begin or start with number 27 in the Test 1 Math 145 review packet. So 27, it says, what are the three possible outcomes when solving a 2x2 system of linear equations? So we can have one solution, no solutions, or infinite number solutions. So really, there's only three outcomes: one solution, no solution, or infinite solutions. Graphically, this is what it would look like. One solution, you'd have two lines that intersect one time. No solution would be parallel lines. And infinite solutions would be a line that's on top of a line. So every point on the line is intersecting because the lines are on top of each other. All right? Call that coincident. Number 28 says, use your graphing calculator to solve the following system of equations graphically. So again, we know how to solve systems graphically by the method of substitution, the elimination method, the addition method, but here they're specifically saying graphically. So we have to rewrite these equations in terms of y, meaning get y by itself, because our calculators, when you press y equals, start with a y, right? So instead of typing in 6x plus 3y, we have to get y by itself. So I subtract 6x from both sides and then divide everything by this 3 to get y by itself. So I'm going to enter this in the following way. Minus 6x, notice I started with parentheses, minus 7.5, and then divide this whole thing by 3, that's my y1. y2, I'm going to have to bring the 2.5x over and then divide everything by negative 1 to get y by itself. So that's 2.5x minus 7. So these numbers all look pretty small. So I'm going to try a standard window, which is 10 tick marks in every direction. So if I press window, right, I want to go from maybe negative 10 to positive 10 in every direction. You can manually do that, but a quick way would be type the zoom key and number 6 for standard. And that will give us 10 tick marks in every direction. There's the first line. Here comes the second line. Okay, and we want the intersection. So I press second, trace, number 5 for intersection. It says first curve, okay, that's the blue line. Second curve, that's the red line. Guess where do you think the intersection is? That's right around here. I press enter. Now it says the intersection is at 1, comma, negative 4.5. Right? 1, comma, negative 4.5 is the intersection. So that's the solution to my answer, right? Let's just write this down. The answer would be 1, comma, negative 4.5. Most teachers would not just accept that, right? If you solve by graphing, they're going to want you to sketch the graph, right? It doesn't have to be a Picasso, but maybe you label it X and Y, right? And at 1 comma negative 4.5, we know we have an intersection. So maybe that's somewhere down here. 1 comma negative 4.5. And we would have a line that did this, and another line that did that, and this was our intersection. Hopefully yours will be a little bit neater than mine, but that's how we solve by graphing, right? Enter the information into your calculator, press second, trace, number 5 for intersection, and press enter 3 times. Okay, that's number 28. Let's go to 29. Okay, now it says use your graphing calculator to solve numerically. That just means get a table. This is my least favorite method. I prefer to graph or use substitution or something, but we can solve this numerically. So first we have to graph both of these equations. And again, the bottom equation has to be rewritten as y equals minus 19x plus 710, right? Because we need to get this in the form of y equals mx plus b. So I had to move this 19x to the other side by subtracting 19x from both sides. The first equation is fine the way it's written. So let's put this into our calculator. Here's my calculator. I took the liberty of entering the 47x minus 1930, which is my y1, and my y2. Remember, I had to bring this 19x over, so it becomes negative. Okay, now we're asked to solve this numerically, so we don't have to really worry about the window. But our table, we probably want to set up our table by going second, window, because above window it says table set. I'll start at 0 and I'll count by 1. And then to get my table, I press second and graph. And what we're trying to find is what value of x will make my y1 and y2 be equal. So right now, we're not even close, right? You see how we're at minus 1900, minus 1400, and we're trying to get down to a value where y1 is going to equal y2. And it looks like y2 is getting smaller as y1 is getting bigger. So at some point, they're going to meet. Let's see. It looks like we're getting closer and closer. Now, I could have set up my table to count by 5s to get, down here quicker. But let's see. We're getting close. I want to see, when does y1 get positive? We're getting close. Oh, there it is. Uh-oh, I hit the button too many times. But you can see when x is 30, no, when x is 40, y1 and y2 are both 50, negative 50. Now I hit the button too many times, so I get to pause for a minute. So you can see when x is 40, my y1 and y2 are negative 50, okay? So the intersection occurs at 40, comma, negative 50, all right? So again, if I was going to solve this on paper, yeah, you have to, write your answer, 40, comma, negative 50. But you should also show a table, right? Since this is the numerical method, you would show 3 rows and it's not my best work for sure. All right, so this would be my x, my y1, and y2. And if you look at the calculator, right, when x was 40, y1 and y2 were negative 50. So in the middle, you'd put 40. And you'd want one row above and one row below. So 41 was 3, comma, negative 69. Or negative 3, negative 69. And then we have to put in for 39. That would be negative 97, negative 31. Right? And this is our winner. Right? So that's a numerical method. Again, not my favorite. You have to draw a table. I prefer graphing or one of these other methods, substitution, elimination, addition method. So let's do one of these. So if I was to solve number 30, I think it's set up for substitution because y equals everything I just circled. So I can replace y with everything I just circled, right? So instead of 3x minus 4y, we know that y equals everything I've circled, so I can put in negative 2x plus 9, and that all equals 8, right? Looking at this bottom equation. So we do the math, we get 3x plus 8x minus 36 equals 8. Okay, and then we put the x's together to get 11x minus 36 equals 8. Then we could add 36 to both sides to get 11x equals, what is that, 44. Divide by 11, x equals 4. But that's only half your answer. We need the value for y, right? We need x and y. So if I plug in 4 to x, right, you're left with y equals negative 2 times 4 plus 9, or y equals negative 8 plus 9, or y equals 1. And as an ordered pair, you would write 4, comma 1 as your answer for number 30. Okay? Let's do one more. So I'm going to leave this up. I want to erase this, and I'm going to do number 31. So I'll just leave this up for a moment. Okay, let's do number 31. So I'm going to rewrite 31 over here, just so we have more room to work. Now, the last problem I used substitution. For this problem, I'm going to use the elimination method. So we're going to try to eliminate one of the variables. So I see I have a negative 4y on the bottom. If I multiply the top by positive 4, look what happens, right? This becomes 8x plus 4y equals 12. The bottom equation we don't touch, right? And let's see, hold on for a second. So I want to add these two together, right? Remember, this is the elimination method. So we've just eliminated the y, right? So I get 16x equals 20. If I divide everything by 16, I'm left with x equals 20 over 16, which is the same thing as saying 5 over 4. Okay? So that's one of my answers, 5/4 or 1.25. Now to find, so I know that's what x equals, right? Or you could write it as 1.25. To find my y, I need to substitute this value for x, either one, into, I could put it here or here, right? But since I'm looking for y, I'll use the top equation, right? So let me just rewrite the top equation. It's 2x, but instead of x, I'm going to put in the 5 over 4 plus y equals 3. Again, that's coming from this equation here. So let's see, this becomes 10 over 4 plus y equals 3. Almost done. I subtract 10 over 4 from both sides. And I get y equals 3 minus 10 over 4. Now, if you want to use your calculator to get to do it, that's fine. I could make this 12 over 4 minus 10 over 4, right? Because 12 over 4 is the same thing as 3. And that would give me 2 over 4, or 1/2, right? So y equals 1/2, or 0.5. So your ordered pair, right, is coming from here, right? You would write either 5 over 4, comma 1/2, I would accept that, or you would write 1.25, comma 0.5, I would accept that as well. Right, so either of those answers would work for me. That was number 31. Again, I'll leave this on the board for a moment. Maybe you want to pause your screen if you want to write this down. And then we'll do number 32. You know what, actually, I'm going to do number 32 in the next video. So thank you for watching.